students, welcome to Meetu Maths classes. Today's topic is from class 12, your chapter 7 integrals, and we are going to solve some important questions of miscellaneous exercise. So let us start with our first question, that is evaluate integral e raised to power 3 log x into x raised to power 4 plus 1 raised to power minus 1 dx. Now to solve this integral, we can write our integral as e raised to power, we can use m log n can be written as log of n raised to power m. So by using this property of log, we can take this 3 in the power of x. So x e raised to power log x cube, and something raised to power minus 1 can be written as 1 upon x raised to power 4 plus 1 dx. Now we can use that exponential and logarithmic functions are inverse functions, so whenever they will multiply, they will become identity and you will get x only. So we can write e raised to power log x cube as x cube only. Okay. Now we can do one thing. We can make substitution. We can substitute x raised to power 4 plus 1 as t. So 4 into x cube into dx can be replaced by dt. Now here we can multiply and divide by 4. Now Ri will become 1 upon 4. 4x cube dx can be replaced by dt. So integral dt, and our integrand will become 1 upon t, and integral of 1 upon t is log t plus c. Now we are going to replace t by our t is x raised to power 4 plus 1, and this is your final answer for the integral. Your next question is question number 17 of miscellaneous exercise, that is evaluate integral f dash ax plus b into f of ax plus b raised to power n. Now to evaluate this integral, we can observe that Ri is, there is written the derivative of f of ax plus b, and your integral is f of ax plus b raised to power n. So we can substitute f of ax plus b as t because its derivative is written in the multiplication. If we differentiate this with respect to x, so we will get derivative of f of ax plus b with respect to x. In turn, using chain rule, the derivative of ax plus b is a into dx is equals to dt. So Ri will become derivative of, we can multiply and divide by a here. Now f of f dash ax plus b into a into dx, they can be replaced by dt, and we are left with t raised to power n, and the integral of t raised to power n is t raised to power n plus 1 upon n plus 1 plus c. Now we are going to replace t by, what is t? F of ax plus b, this raised to power n plus 1 plus c, and this is the solution of our integral. Now your next question is question number 18 of miscellaneous exercise, that is evaluate integral 1 upon square root sine cube x sine x plus alpha dx. Now to evaluate this integral, let our I is integral 1 upon, you can do one thing कि आप एक साइन, क्योंकि साइन क्यूब एक्स है तो इसको साइन रूट से बाहर निकालने के लिए यू कैन मल्टीप्लाई बाय 1 साइन एक्स and you can divide also by sin x within square root, then it will not change your integrand. Now sin raised to power 4x का स्क्वायर रूट विल बिकम साइन स्क्वायर एक्स. तो ये साइन स्क्वायर एक्स बाहर आ जाएगा और स्क्वायर रूट के अंदर क्या रह जाएगा आपका साइन एक्स प्लस अल्फा अपॉन साइन एक्स dx. Now it 1 upon sin square x can be written as cosec square x upon स्क्वायर रूट के अंदर यू कैन अप्लाई साइन a प्लस बी का फॉर्मूला. तो साइन a प्लस बी का फॉर्मूला आपका क्या होता है, दैट इज साइन a cos b प्लस cos a एंड साइन b. तो यहां पर आपका साइन x प्लस अल्फा कैन बी रिटन एज साइन x cos अल्फा प्लस cos x इंटू साइन अल्फा अपॉन साइन x dx. नाउ इट विल बिकम, न्यूमरेटर में आपका cosec स्क्वायर x है, डिनोमिनेटर में इफ यू डिवाइड sin x cos alpha with sin x then you are left with cos alpha, and if you divide cos x sin alpha upon sin x you will get sin alpha into cot x, okay, dx. Now you can observe that sin alpha and cos alpha are constants, so you can substitute this as t because its derivative is written in multiplication. So you are going to put cos alpha plus sin alpha into cot x as t. तो cos alpha का derivative will become 0, sin alpha is coefficient and the derivative of cot x is minus cosec square x into dx is equals to dt. So cosec square x into dx is equals to minus 1 upon sin alpha into dt. Now we are going to replace cosec square x dx with minus sin alpha minus 1 upon sin alpha dt. So your I will become minus 1 upon sin alpha dt and your integrand will become 1 upon root t. 1 upon root t. Now 1 upon root t का इंटीग्रल आप कैसे करेंगे, इंटीग्रल ऑफ t रेज़्ड टू माइनस हाफ dt, दैट इज t रेज़्ड टू माइनस हाफ प्लस 1 upon माइनस हाफ प्लस 1, दैट इज t रेज़्ड टू हाफ upon half, that is 2 root t plus c. And now we are going to replace t with our function, and our t is cos alpha plus sin alpha cot t, cos alpha plus sin alpha into cot x plus c, or you can write this function as sin x plus alpha upon sin x plus c, and this is your final answer for your integral. Now your next question is question number 19 of miscellaneous exercise, and that is a very important question. And your question is evaluate integral sin inverse root x minus cos inverse root x upon sin inverse root x plus cos inverse root x dx. We know and the property of inverse trigonometric function that sin inverse something plus cos inverse something, if the angles are same then sin inverse root x plus cos inverse root x will become pi by 2. So your denominator can be interchanged with pi by 2. So you can write it as 2 by pi integral sin inverse root x minus cos inverse root x dx. Now we can replace cos inverse root x with pi by 2 minus sin inverse root x. So replace cos inverse root x by pi by 2 minus sin inverse root x. So it will become 2 by pi sin inverse root x plus sin inverse root x will become 2 sin inverse root x minus pi by 2 dx. If you multiply these two, we will get 4 by pi integral of sin inverse root x dx minus 2 by pi when multiplied by pi by 2, it will become 1. And your I can be written as 4 by pi into, let us take this integral as I1 minus x plus c, and let us take this statement as your first statement. Now we are going to evaluate this I1, that is sin inverse root x dx, and for this we can make a substitution, that is very simple substitution. We can put root x as sin t. So x will become sin square t, and by differentiating dx will become 2 sin t, and sin t in turn the derivative of sin t is cos t dt. So our I1 will become sin inverse of sin t, and dx can be written as 2 sin t cos t dt, and this can be written as sin inverse sin t can be written as t, and this will be sin 2t dt. And here we can use, since it is the product of two functions, we can use by parts, and by parts this will be algebraic function will be your first function and trigonometric will be your second function. So by using by parts, our I1 will become first function as it is integral of second minus integral of derivative of first integral of second dt. Then t integral of sin 2t is minus cos 2t upon 2 minus derivative of t is 1, and integral of sin 2t will again be minus cos t upon 2, and this will become minus t cos 2t upon 2 plus half integral of cos 2t dt. And now integral of cos 2t will be sin 2t upon 2, and it will become sin 2t upon 4 plus c. Now I1 को आपको ने जो सब्स्टिट्यूशन किया आपने t, now you are going to replace t by x. Now our substitution was root x is equals to t. So our substitution was root x is equals to t sin t. So x is replaced by sin square t, and if sin t is root x, then cos t is equals to square root 1 minus sin square t, that is square root 1 minus sin square t is x. So cos t can be replaced by root of 1 minus x. Now we can do one thing. We can write cos 2t as 1 minus 2 sin square t upon 2 plus here we can write sin 2t as 2 sin t cos t plus c. Now put t. T is sin inverse of root x. So t is sin inverse of root x, and this will become 1 minus 2 sin square t is x upon 2 minus this will become 1 by 2 sin t is root x and cos t is 1 minus root of 1 minus x plus c. So this will become minus can be taken inside, so it will become 2x minus 1 upon 2 sin inverse root x प्लस 1 by 2 स्क्वायर रूट के अंदर अगर आप मल्टीप्लाई करेंगे यू विल गेट x minus x square plus c. So this will be the your I1. Now substituting the value of I1 in 1. So 1 will imply your one statement was this. So 4 by pi times I1, your I will become 4 by pi times I1. I1 is 2x minus 1 upon 2 sin inverse root x plus half square root x minus x square minus x plus c. And your final answer for I will be 2 will cancel out, 2 by pi 2x minus 1 sin inverse root x plus this will become 2 by pi square root x minus x square plus minus x plus c, and this is your final answer for the integral. Now your next question is question number 20 from miscellaneous exercise, that is evaluate integral square root 1 minus root x upon 1 plus root x dx. Now to solve this integral we can, our integral is square root 1 minus root x upon 1 plus root x dx. Now here we know the formula for 1 minus cos 2 theta and 1 plus cos 2 theta, so we can make a substitution. We can put root x as cos theta. So our x will become cos square theta, and after differentiating we can replace dx by 2 cos theta, and derivative of cos theta is minus sin theta d theta. So our I will become integral square root of 1 minus cos theta upon 1 plus cos theta into dx is replaced by minus 2 sin theta cos theta d theta. Okay. Now by using the formula for 1 plus cos 2 theta is equals to 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. These are two half angle formulas. So by applying 1 minus cos theta, our theta will be halved. So it will give you 2 sin square theta by 2 upon 2 cos square theta by 2, and here minus 2 is there, sin theta cos theta d theta. Okay, 2 will cancel out, it will give you tan theta by 2 or sin theta by 2 by cos theta by 2. Now you can do one thing, you can replace sin theta by 2 sin theta by 2 and cos theta by 2. इसका फायदा आपको क्या होगा कि आपका जो ये cos theta by 2 है वो कैंसिल हो जाएगा, and you are left with -2 हाँ बाहर ले सकते हैं, and you will -2 you have taken out, and 2 sin theta by 2 into sin theta by 2 is sin square theta by 2 into cos theta d theta. Now 2 sin square theta can be written as 1 minus cos 2 theta. So it can be replaced by 1 minus cos theta into cos theta d theta. So it will become -2 cos theta minus cos square theta d theta. Now it will become -2 cos theta can be integrated, and minus minus plus 2 cos square theta आप रिप्लेस कर सकते हैं किससे, 1 प्लस cos 2 थीटा से. नाउ यू आर गोइंग टू रिप्लेस cos थीटा का इंटीग्रल sin थीटा, तो -2 sin थीटा आ जाएगा आपका. ओके, एंड हियर यू कैन रिप्लेस 2 cos square theta by 1 plus cos 2 theta d theta, and the integral of 1 is theta and integral of cos 2 theta is sin 2 theta upon 2 plus c. Now we are going to replace theta back in x only, and our substitution was root x is equals to cos theta. So root x cos theta है, तो theta will be cos inverse of root x, क्योंकि आपको theta को रिप्लेस करना पड़ेगा, and cos theta अगर root x है तो sin theta will be square root 1 minus cos square theta, that is square root 1 minus x. Okay, now we can write I as -2 sin theta plus theta, and this is 2 sin theta cos theta upon 2. 2 will cancel out. Now by replacing theta back in x, sin theta can be replaced by square root 1 minus x. Theta can be replaced by cos inverse root x. Sin theta is square root 1 minus x, and cos theta is root x plus c. So your final answer will be -2 integral 1 minus x plus cos inverse root x, plus you can multiply in between square root, and this will give you your final answer.